Good afternoon, everyone. Right, just quick recalls. Just make sure you're very confident with this. Right, complete those two sentences. Okay, give it a go yourself. So hopefully by now you know that log a base a, if those two things are the same, is equal to 1. And log a x to the n, that exponent can be brought to the front over here. So it's going to be equal to n log x base a. Right, a rule that we haven't really used yet is your change of base rule. So say we wanted to get this to some different base, let's say base b, okay? So we get them both to base b. Then this bit over here goes to the top, and this bit over here goes to the bottom. The a goes over here, so it'll be log x base b. You get to the same base, top and the bottom. That goes to the top, that goes to the bottom. Right, get that down, please. Good day. So I just want you to try and prove this. Okay, that log a base x will be equal to 1 over log x base a. Okay, so give it a go. It's quite fun. It's not too bad. It's a few lines. Okay, so my proof, I'm starting with log x, log a base x, right? But I look and I say, okay, I need a base a. Okay, so the change of base rule says, okay, I want base a here at the top, and I want base a here at the bottom. And then what happens? That bit goes to the top, okay, and this bit goes to the bottom, okay. And log a base a is equal to 1, so it's equal to 1 over log a x. So you can remember this. It can be quite useful, but it's also not the end of the world if you don't, because it's pretty easy just to derive it. So in other words, if I gave you this, log x base 3, you can go through the steps if you want to, but you also can straight away say, okay, this law is saying that those two things swap around and I'll make it 1 over that. So if I swap them around, it becomes 1 over log 3x. Those are swapped around compared to the original log, okay, and it's 1 over that. So if I gave you log, I don't know, 7x, and I wanted base x, you log base x, it will be 1 over log, and they swap around, okay, like that. So you're welcome to use that. Okay, it's quite a nice little proof. Okay, but as I say, you don't have to remember it off by heart. You can just use your change of base and derive it every single time. Lovely stuff. The next proof I want you to try is to prove that log x base 1 over a is negative log x base a. So in other words, we want to change a fraction, okay, flip that around, and we've got to put a negative in front. Okay, and to do the proof, once again, you're going to use your change of base rule. So give that a try. It's quite fun. Okay, so we start with the left-hand side, log 1 over ax, but I need base a, right? So I'm going to say, okay, I want base a. So I'll go base a, right? Then what happens? This bit over here goes to the top, so that's x. This bit over here goes to the bottom, so that's 1 over a. Sorry, 1 over a. So then, okay, well that is going to keep the same, which is looking promising because it's similar to that. And 1 over a, well, what can I do with 1 over a? I can write it as log base a to the negative 1. Okay, and I have log ax, okay, negative log a base a. Okay, but this, ladies and germs, is equal to 1. So I get log ax over negative 1, which is negative log x base a. So again, quite a nice simple proof. You don't have to learn it by heart, okay, but it can be useful with inner sum. So this might be worth remembering, can save you a bit of time, so you don't have to go through all of those steps. So quite simply, if I say to you, you've got log x base 1 over 3, and I want you to write it with base 3, all that you have to do is put a negative in front and flip the fraction around. So you can just use that. You don't have to, with inner sum, you're welcome to just do that step. You don't have to go through that whole process over there. And if I said this, write it with base 10, well, log 0,1 means log 1 over 10x. Okay, and I can write that, put a negative in front, flip the fraction around, and you can write it as negative log x base 10. Okay, as you should know by now, you don't even have to have that 10 there. You can just write it as negative log x. So you're welcome to use any of those two rules that we've just derived. Good day, Brogan. But you don't have to. You can simply derive it within a sum. Hallelujah, we are back, and the family is waiting for lunch. I'm going to try to be quick. Okay, so hello everyone. Hello family. Right, solve for x. So I've got log x minus 2 base 8, so, and then the whole thing over there. Question, these examples come from exercise 4 of Mindful Maths, page 106, and we're doing 1a and b. Question is solve for x. Straight away, you've got to watch out now for, I can't go use a log law for subtraction straight away because the bases are different. So until I get the bases to be the same, there's nothing I can do. Okay, but we do know this, that log x 1 over a is negative log a x. So first of all, go change that base over there. Give that a go, get that to base 8. Okay, so Brogan, as you can see, I can see you riveted, log 8x minus 2. Okay, I'm going to rewrite log 1 over 8x minus 6 as negative log base 8 of x minus 6. Okay, and that's going to be equal to, well, let's make that an improper fraction. 3 plus 2 is 5 over 3. Well, straight away we're solving a log equations. Okay, we should put our restrictions down. So x minus 2 must be bigger than 0, so x has to be bigger than 2. And likewise, x minus 6 has to be bigger than 0, so x has to be bigger than 6. So overall, x has to be bigger than 6. Right, and if I simplify this, so go from there and try to finish that off. Okay, that's now nothing new. Give it a go. So, I get log 8 x minus 2. That's going to become plus, you can skip out the step. Log base 8 x minus 6 is equal to 5 over 3. Okay. I can now use a log law because the bases are the same. Okay. And if the bases are the same, I can rewrite that as log base 8 x minus 2 x, that's a 2. Let's write neatly, x minus 6, okay, is equal to 5 over 3. So therefore, if I use the definition, I can say that 8 to the 5 over 3 must be equal to x minus 2x minus 6. And believe it or not, you can do that without a calculator. Why? Because 8 is the same thing as 2 cubed. So I've got 2 cubed to the 5 over 3, which will be 2 to the 3's will cancel. You'll be left with 2 to the 5, which is what, Brogan? 2 to the 5 is 32, is equal to x squared minus 8x plus 12. So 0 is equal to x squared minus 8x minus 20. So 0 is equal to x minus 10 x plus 2. So therefore x is equal to 10, or x is equal to negative 2. I don't know if you can see this behind these. Okay, so x is 10 or x is negative 2, but then check your restrictions. And x has to be bigger than 6, so negative 2 cannot be valid. So there is your answer. Check that that makes sense, get it down, and we'll do one more example, and then we're done, and we can all go have lunch. Greetings and salutations. Right, last example, solve for x. Okay, it comes from 1b of exercise 4, page 106. 2 log x base 9 plus log 81x is equal to 5. Well, we've got a problem because your bases aren't the same. So, if I go use my basic change of log law, it will become 2. I'm going to leave, try to get everything to, no, I want everything to base 9. At the moment it's base x. So try to rewrite that using your basic change of base rule with base 9. So I'll have log base 9 at the top and log base 9 at the bottom. Okay, then what happens? Well, the 81 is going to go to the top. Okay, and the x is going to go to the bottom. And that's going to be equal to 5. Right. Now we've got to just go simplify this. Okay, and log 981. Okay, I'm just going to do it on the side here. Log 81 base 9. Well, the question is saying 9 to the what is 81, so you can just write the answer down. That's going to be 2. If you've got that, you're going to say log 9. You don't have to show all the steps. is 2 log 9, which is equal to 2 times 1, which is 2. So 9 to the what is 81, 9 squared is 81, so it becomes therefore 2 log x base 9 plus 2 over log x base 9 is equal to 5. So now we've got those two things are identical, there are no other variables, so I can do a substitution. So we're going to let k be equal to log x base 9. So therefore 2k plus 2 over k is equal to 5. So therefore 2k squared plus 2 is equal to 5k. So therefore 2k squared minus 5k plus 2, how much fun are we having? So much fun. Plus 2 is equal to 0, and that can be factorized to 2k, k, negative 2, negative 1. Just check 2k squared minus 5k plus 2 is equal to 0. So therefore, k is equal to a half, or k is equal to 2. But what is k? K is log x base 9. So therefore, log x base 9 is equal to a half, or log x base 9 is equal to 2. If I use the definition, I get 9 to the half is equal to x, or 9 squared is equal to x. So I end up with, well, 9 to the half is the square root of 9, which is 3. So x is equal to 3, or 81 is equal to x. Okay, I should have done a restriction in the beginning, and the restriction would have been, well, x has to be bigger than 0, but also because it's a base, x can't be equal to 1. The answers then are fine. X is equal to 3 and x is equal to 81 are perfectly valid. Fantastic. Right, all that's left to do is for you to work through the examples on page 105 of Mindborn Maths, your calculus and algebra book. Do all of exercise 4 on page 106, well, all except A and B, which we have done in class. And that, ladies and germs, is that. Farewell and have a lovely day.